So we've seen in earlier lectures by Johnny and Nicole how to process imagery from the original folder of photos into sparse clouds and then into dense clouds within Agisoft Metashape. In this lecture, I want to show how to go from the dense cloud to products that are derived from the dense cloud, including a digital elevation model, or DEM, an orthophotomosaic, and a meshed model. Let me reiterate that these steps are universal regardless of the software that you're using. It's just that we'll illustrate how to do it here with Metashape, but any of the other photogrammetric modeling packages that you might use for large area imaging would do these same steps and they'd make the same products. So let's first look at the mechanics of how to make these, and then we can circle back and discuss some of the details. For this example, I'm going to use data from a coral restoration site near Miami, Florida, that's shown here. The full data set is about 9 by 12 meters in size, and we've used just over 2,000 images to make this model. It takes several hours to run all of the steps to build a model this size. So in the interest of time for this demonstration, I've just pulled out a subset of 69 images covering just a small section of the whole plot. By the way, I've posted these on the course website if you want to download them and try it yourself. Here, we're starting at the point where the previous videos left off. Namely, we've already imported the images, we've aligned them to create the sparse cloud, or the tie points shown here, and then we've run the step to create the dense cloud. If you pull down the workflow menu, you'll see that new options that were originally grayed out are now selectable. Build Mesh and Build DEM are the next ones we want to try. The Build Mesh dialog box is pretty simple. Really, the only choice here is the face count, which is just a measure of how detailed do you want the model to be. I'll try here first a low face count and then a high one so you can see the difference. When the computation is done, you can use this button here or the Model View Mode menu item to view the mesh model. There are 3 modes to view it: shaded or colored, solid, and wireframe. If you zoom in on the wireframe model, you can see what the mesh is. In fact, a network of triangles, also known as a TIN, or a triangulated irregular network if you're a GIS user. Here, I'm showing the differences between the high face count on the left and low face count on the right, the high quality modes for this model. First, I'm showing how the face count model has. First, I'm showing how the high face count model has obviously more triangles, and then showing how having more triangles translates to a more detailed looking result. The Build DEM dialog box is also pretty simple. I almost never change the default values here. The only time might be if I were working with a really gigantic model and running out of memory. In that case, I might change the resolution to be lower. Otherwise, just leave the default here and click OK. When the DEM calculation is done, you click on the Ortho tab to see the result. The first thing to notice here is that unlike the point cloud or the mesh versions of the model, the DEM is flat. You can zoom and pan on the DEM, but you cannot rotate it in 3 dimensions like for the point cloud. The second thing to notice is that the colors here represent relative heights. Red is closer to the camera and blue is further away. The absolute values of these don't really have meaning, but the relative values do. The difference between the highest point here and the lowest is 32 minus 39.9, or about 1.08 meters. In short, any relative difference between 2 points is accurate, but the absolute values are not. Once you have either a DEM or a mesh, you can make an orthophotomosaic. On the Build Orthomosaic dialog box, you can pick DEM or mesh as the source. I would leave the blending mode as mosaic always and enable hole filling. Here, I sometimes do pick a particular pixel size. I tend to like round values like 1 centimeter or 1 millimeter or 0.5 millimeters or something like that. Here I'll pick 0.5 millimeters as an example. The refined seam lines and enable ghosting filter can help reduce artifacts in your mosaic at the cost of increasing processing time. Refined seam lines in particular takes a long time. You can play with those if you find artifacts in your example, but I'll leave them unchecked for now. Also, for the moment, you can leave the projection as the default top XY here. We'll discuss this in a later video. Click OK and let it run. Like the DEM, the orthophotomosaic shows up in the Ortho tab when complete. Also, like the DEM, it's a 2D product, so you can only pan and zoom only. You can switch back and forth between displaying the DEM or the mosaic with these buttons up here on the toolbar. One last point is that you can export all of these products using the File Export menu. What you would export would depend on the type of analysis you're trying to do. So here I'm showing an updated version of the workflow cartoon to show some of the many export options. This isn't comprehensive, but it gives you an idea of the flexibility of these tools and the options that you have for analysis once you've created these models and their derived products. I also want to emphasize that the tools for doing the analysis vary depending, let's say the best tools for doing the analysis vary depending on what type of product you're exporting. So that's it for the basics of making the so-called derived products: digital elevation models, meshes, and orthomosaics.